And here we have the signal provided. The signal name is x of t. And the questions here is asking write x of t in terms of unit step and ramp functions. Now let's see how we can express this one in a function like x of t signal. How we can express this one using unit step function and ramp functions. So first of all, we have to know that unit step function, it goes up one and go with straight line, and ramp function go with one slope is 1 and it goes to infinity with slope of 1. Okay. Okay, so here you can see until 0 we don't have anything, but at 0 we have a jump of 1 and it goes like flat with 1. This is a unit step function, so we can say that is u of t. And at 1 what do we have? We have a slope going up, so that's why I put a plus right here. And then this is a positive slope and slope of 1. So this is a ramp function, and the ramp function begin at 1, so there's a shift of 1. Ramp function is described by r of t, but if we have a shift 1 unit to the right, we have to express this one as r of t minus 1. And then at 2 the slope is going down, so this is minus, and the height at that point is 2, so we have to put the 2 in front. And then r of, so there's a shift 2 units to the right, so this is t minus 2. And then plus, and here's where you have to be careful. We are coming from here, right? The slope is going negative 1. In order to make this one flat, so the slope is negative 1. You may think this is a flat, so we can put a unit step function. No, because if you put a unit step function right here, it's going to jump up 1 unit up and goes like this. So that's not what we want. We want a flat like this. So this is a negative slope, negative 1 slope. And to make this one into a 0, like 0 slope only goes flat. So we have to add a positive 1. Positive 1 plus negative 1 becomes 0. So this is, we have to add a ramp function, because a positive ramp function has a slope of 1. So 1 and minus 1 makes this one 0 flat like this. So we have to put positive r right here, and then this is happening at 3, so there's a shift right. This is at 3, so we have shifted 3 units to the right, so this is t minus 3 right here. And then plus at 4 it's having a jump and going 1 forever, so 1 until this. So this is a unit step function, u of t, and 4 units to the right, so minus 4. And after that it's going down by from 2 units going down, so minus 2, and it's going down mean it is a u of t as well. So this is u, and this is happening at 5, so u of, okay, let me take out the bracket, we don't need it. U, because this is going from 2, like the height is 2, that's why we have 2 in front, and it's going down, that's why we have a negative, and then u, and this is happening at 5 units to the right, so this is t minus 5. Okay, and that's how we can express this. Now to verify whether this is right, you can always plug a number and check with the graph. Now let's try number 2, like checking. Check. Let's pick a random number, x of 2. If you put x of 2, then this u become, because the time is 2, so this is u of 2, and then this is r of 2 minus 1, that is r of 1, and then this one becomes r of 2 minus 2, that's r of 0, and then plus r of 2 minus 3, that's negative 1, r of negative 1, and then plus 2 minus 4, that is r of negative 2, I mean u of negative 2, and then minus minus 2u, and then 2 minus 5, that's minus 3. Okay, here you have to know one thing, that whenever we have a negative unit step function, that is 0, because unit step function is 0 until 0, and at 0, like when it's less than 0, it is 0. When it's equal to or greater than 0, it becomes 1. So here this is less than 0, so this is going to be 0 right here, and this is also less than 0, so this is 0 right here. Ramp function also same, but ramp function, like less than 0 equal to 0, it's 0, but after 0 it becomes a time t. So here this is negative 1, so it's less than 0, obviously this is a 0, and r of 0 are also 0. So these are the things we have to calculate. U of 2 and r of 1. U in positive, like 0 and positive values, u always 1. So this is just 1 right here. And r of 1 depends on the time. Like if the time is 1, r is 1. If the time is 2, the r of 2 function is 2. So it depends on the time, like because the slope is 1, so the time determines the ramp function's value. So since the time is 1, this whole thing is going to be 1. 1 plus 1, true. Now let's check the graph. At x is 2, what's the y value? So here you can see this is 2. Okay. So we can say this is right, and we can try one more thing. Like we can plug in like x of 5 and see what we are getting. So u of, first we are going to have u of 5, we are plugging time value with 5, so u of 5, and then 5 minus 1, that's r of 4, and then minus 2, r of 5 minus 2, that is 3, and then plus r of 5 minus 3, that is 2, and then plus 5 minus 4, that is 1, and then minus 2 u of 5 minus 5, that's 0 right here. So let's look at this. Let's cancel, let's take care of the zeros first. So here u of 0, that's 1, so we don't have any negative value or 0, so everything has a value, so we have nothing to cancel here. U of 5, 0 and positive values, u is always 1, so this is u of 5 is 1. R of 4, the ramp function always take the value of the time, so if the time is 4, ramp function is 4, and then here 2 times ramp function is 3, so this is going to be 3 as well, and then ramp function is 2, so this is going to be 2, and then u of 1, u is 1, 0 and positive value, so here is the positive value, so that's 1, and then u of 0 also 1. Okay, now let's calculate this. So this is 5 minus 6, and then plus 3, and then minus 2. If we calculate, 5 minus 6 is negative 1, negative 1 plus 3, that's negative 1 plus 3 is positive 2, positive 2 minus 2, that's 0. So at 5 time it should be 0, and that's what we have right now. At 5 we have this one is 0. So it means what we did is right, and we checked 2 of the things and verified our function equation is right. And that's how we construct signal if we have a graph provided like this. I hope you guys find this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.